All right, this is the video that goes along with coloring in your orange and blue periodic table of the elements. It is how we are going to learn the polyatomic oxy-anions. So there's a series of oxy-anions that are very popular, and you need to know them for your polyatomic ionic formulas. Poly means many, and atomic is many atoms. And then oxy is they contain oxygen, and then an anion means it's a negative ion. So all of those words do indeed, all those parts of the words mean something. All right. So we're going to first look on a regular periodic table of the elements and see the elements that we're talking about. There are going to be some that are going to be highlighted in blue and some that are going to be highlighted in orange. They're going to be highlighted blue or orange based on how many oxygens they have. So first of all, eventually you'll have to know which ones are orange and which ones are blue from looking at just a regular periodic table of the elements. So I'm going to hand out to you a blank copy of a polyatomic oxy-ion chart, and it is not just the regular elements. You can see here regular periodic tables just have one element per spot. Okay, so number 22 and 23, 5, 6, and 7, 9, 17, 35, 53, and 85, and technically speaking 117, although there are no compounds that use that, are all going to be highlighted blue on your periodic table. And then the orange ones are going to be 24 and 25, 42 and 74, 15, 16, 33 and 34, and 51 and 52 are going to be the orange elements. So the paper that I gave you looks like this. And you'll notice it's not just the elements on this chart. They have like oxygens with them and charges with them on here because it's how you're going to memorize those particular ions. So let's look at the color-coded one, and we'll look to see what is the difference between the orange ones and the blue ones. So look over, this is the end product of what you're going to color in. Look over all of the things that are orange and see if you can tell what they all have in common. All right. So if you notice, every single orange colored in square has 4 as the number of oxygens in their ion. All right. So orange ones are O4 when they say 8. Everybody on this chart is listed here as the 8 variety, which is their top of the line, is their 8. The blue ones, when they have an 8 ending, are O3. Now, they're not listed on this chart, and you have no separate chart that reminds you that 1 less is 8. You just have to know that 8 is the bigger one and 8 is the smaller one. The way I memorized it is I got bigger because I ate. So the bigger ones are the 8 versions of the elements on the periodic table. And the 8 versions are the smaller ones. So the orange ones start out 4, and then the 1 less is 3, and the blue ones start out 3, and the 1 less is 2. The way I memorize that the orange ones are the O4 ones as their top of the line is that you go to West Orange for 4 years. So the orange ones are O4 for orange 4. Okay, so if you look, you also have to know their charges. And if you remember this past week's learning of the regular ions, most of these are very similar. So if you look, everything over in the halogens column is a -1 charge, but that's what they were before. So that's not learning anything new. And the elements number 16, 34, and 52, they're all 2 away from the closest noble gas, and they used to all be -2, and they still are. 15, 33, and 51 are all 3 away from the closest noble gas. As an element by themselves, they're -3, and they still are. So the bus, which is this what I call the orange set of 6 elements, and the loop, which is the bus loop, which is the halogen column here, um, are all the same charges, whether they're by themselves or whether they're polyatomic. There is a difference in the charges of this top row element. I call this section the annex of the bus loop because it's a little offshoot over here, and there's an opening. See, oxygen's not colored in. So if you had to run over to your bus, if it was parked over on this annex, you'd get wet if it was raining. And I say, that's messed up. That reminds me that the formula's charge is also messed up to what it would be as regular elements. And this oxygen looks like a 0 to me on a number line, and their charges are -1, -2, and -3. So it's kind of like a little number line there after this O for oxygen. Everybody over on the left-hand side of the periodic table, which I call the loser team section. Loser because this section makes like an L upside down. And then team because then these 2 added to it kind of make the shape of a letter T. And everybody over there is a -2 charge except for vanadate. Vanadate is a -1 charge. So everybody over here is -2 in the loser team section, except vanadate is a -1. So I remember the whole loser team is -2, except vanadate is -1. So there you go. That's how you kind of learn and memorize the polyatomic oxy-anions. Now there's 3 other noteworthy additions that you will need to memorize. Ammonium, it's our only positive ion that we're going to learn. That's polyatomic, and that's NH4 plus 1. Hydroxide is an OH minus 1. And acetate, which is C2H3O2 minus 1. So those are some additional polyatomic ions that you do need to know. So get to learning them because the quicker you do, the easier formula writing is going to be.